how to keep laboratory records. Before we start this section, let's prepare a tea. So this is a peer-reviewed protocol for making a tea, written on paper and reviewed by another colleague. This has obviously its disadvantages, and we're going to comment them in a second. In the meantime, please open Benchling and Protocols.io and so sign up for them. It should be fairly quick. You should be able to access both of them through your Google email even or any other account. But I suggest that if you don't have a user in them, I suggest you create one with your working email, depending on your preferences. So I'm not an expert on this. Whatever I did on Benchling was free, but I just played with some random projects. So maybe Victoria was going to jump in.
Yeah, I think Benchlings has like different levels of membership. So you can join as a free membership and use certain functionalities. But I think with larger collaborations, you have to go to more advanced. So I think, yeah, I think for our exercise today, maybe some simple projects is okay to use.
So whatever we're going to do now, it's basically covered by the free membership. So, and then for more advanced project, I'm not sure, and this depends on also the agreement of your institutions, I would say. But we can have a look at it together and check if this covers everything that you might be in need of, right? So, jumping inside exercise 1. Compare the electronic version of the T protocol that is linked here in the notes now. Actually, let me copy and paste all the exercise. Okay, so we have the paper version from the photo, and that's also linked inside the shared notes now, and the electronic version of the T protocol. Compare them and discuss the advantages of disadvantages of the two type of records. Can we find at least a couple of advantages and a couple of disadvantages for both? Let's do it here in the main room. The one on paper, it's really difficult to read, and so yeah, definitely reproducibility. But any advantage for the paper one? It's often the case that we have a piece of paper, but maybe not a laptop next to us, like when we're working. Students don't really need instruction on how to use a piece of paper. We can usually read it and start right away. While if this is in Protocols.io or in GitHub or anywhere else, we will need to create an account, access it, and so on. So yeah. I don't know exactly how to take a note of this, but I would say that there's no need to explain the technology behind. Okay, the advantages of disadvantages that were already suggested by the lesson are that the digital record can smoothly and easily move elements. So with it, you can easily move elements around, while it's not so straightforward to do it with a piece of paper. You would need to cut it and do things that, yeah, are not really straightforward. It's findable and accessible because it can be shared instantly and anywhere around the world with anyone. You don't really need to hand them a piece of paper. It's interoperable, but because it can be easily commented by anyone anywhere. Doesn't take up physical space. The regular backups mean it won't be lost. So if you actually schedule regular web backups, this means it won't be lost. It's reusable because the version control can change and can be easily tracked. And it's dependent on, so it's reusable because you can store protocols directly with other supporting data types. The disadvantages of digital record are that it's dependent on internet. Some digital record keeping services charge fees, or they are not free. And there is a risk of corruption if the data is not backed up. Sorry, again, I hear a little bit of background noise. If you can mute your mic, I would be grateful. And the analog records, the advantages would be that you can directly draw your own records. You can work regardless of internet power access, but it can be loss or damages. It's in only one location at the time where the piece of paper is. As we were mentioning, the handwriting can make it less intelligible, and it's harder to edit, move, and you can store multiple data types. Okay. So why do we need to keep quality records? It's a good scientific practice for transparency, reproducibility, and accountability. And I think that so far we've made definitely this point. So in order to avoid the data mismanagement, the fair record keeping is at the cornerstone of all the fair and open science principle. You are legally the one responsible for your records, not your colleague, not your PI. So you are responding for this and the way you keep your data in place. The laboratory record needs to be detailed, kept accurate and complete, and they should be accessible to other both short and long terms. They should be backed up regularly, and they should be kept in compliance with your department, institutional, and other regulatory requirements. So we highly suggest you to check them. Laboratory notebooks are the response to all these needs. They are supposed to contain all relevant details of your experiment, who you are, which project is the record part of, the information on all the lot and batch numbers and everything else that is specific of your equipment or of your consumables, what happened on that day or what didn't happen, how you process and analyze the data, your interpretation of the data eventually, and the next step in the project based on these results. And the lab notebooks should be well organized for easy navigation and should be accurate and complete. Protocols are, I think here we would describe it even more than I do. They are some sort of the abstraction of the experiments. They are the description on how the experiment was conducted. One single protocol can describe multiple experiments, obviously. So the protocol should include who created the protocol if it wasn't you. So you should refer to the original protocol. Should be complete and detailed instruction. Should include complete and detailed instruction describing why and how you did the experiment, what special materials and instruments are needed for the experiment to take place, health and safety advice, and how to dispose of waste, and allow repetition of your procedures and study by yourself and others. So protocols are kind of the blueprint for single experiments. And I think I will skip this because I think we made this point very, very often. Fair records allow findability, accessibility, interoperability, and reusability. And let's go finally to our main exercise. So we're gonna run an exercise together. So you're supposed to follow along what I do in Benchling. And then we're gonna do the same or a slightly different exercise in breakout rooms. So now please follow along what I'm doing. Let's start with accessing Benchling. Can I click on this link? Yes. And I will move here my slides just to keep track of what I'm supposed to do now. So Benchling, if you access, you should end up in a link or in a page that is similar to mine. It has like a get started with Benchling tutorial. The first task can be verify your email address, whether you or not you did it. You should go. So let's have a look at it. Your account here includes several settings, the molecular biology setting, your data expert. You can create or join organization or sign out. Here instead we have some menus. This is the getting started with the bench-link menu. This is the project menus. And here, so if you click on this folder icon and then hit plus, you will be able to create a project. You should call the project breakfast. I already did it, so I'm not sure what will happen now, but let's do it again and check. So you should call the project breakfast, eventually add an appropriate description, which in this case, I don't know, you can write anything, and then click create projects. And I don't know if it will complain or not because I already created it. No, it doesn't. Okay. So now I'm in the project breakfast. And now this means that I do have a main project inside my account. Now, by clicking at the link that should be included in this exercise, so let me grab it quickly and maybe paste it inside the chat. Here. Wait, sorry. Okay. By clicking at this link that I just pasted in the chat, this one, you will be able to access this protocol that was actually open on the side of my projects. So you can select the clock symbol on the right side here to check the history of this project. And as you see, we can check who did change this protocol and when, and all the time span. And these are actually version of the protocol, so we can access any just by navigating this history and checking the differences with our main protocol here. So if someone ever tried to manipulate this protocol, we will be able to spot it here. If we want to adopt this protocol for our own experiment, we are supposed to clone it. So we can, since I'm not sure now which version we are on, we can click again on the last version, so the one on top of the history, and clone it. This button will allow you to clone this version to your own project. It will ask which folder do you want to clone this protocol in. And again, since I did the exercise twice, I actually have 2 breakfast folder. You should have 1 only. By selecting it, we are now importing our protocol, inside. I do have 2 because whatever. Okay, so if we want to adopt this protocol for our own experiment, the first thing we would need is to clone it. Why? Because the original author of the protocol might change it, and we don't want our own protocol, our own experiments to be linked to a document, a living document, so a document that might change. We want it to be linked to the real protocol when we adopted it. So that's why the convention of cloning the projects, cloning the protocol inside your project. And I will stop now for a sec to understand if there are any questions so far. Nope. Okay. So now let me copy and paste exercise 3, which is the continuation. So then when you access your project and your breakfast project inside your projects, you will see just one, not 2 of these protocols. Okay. So again, please feel free to interrupt me if I'm saying things that you don't really see on your screen. So now we have access to a digital record, and we want to reuse it to make our own breakfast. So basically, we want to adapt this protocol to our needs. So we will firstly, so here I just showed you basically that if I open the history of this file of the protocols I just cloned, there are only my changes, not the original one. But the original one is still linked here, so it's still accessible through this link here. And these links open the original protocol here. If I go back to my main one, this is the one that I can safely edit. So I can, for example, go to the top bar here and change the title. I want to remove the mushrooms from my recipe because I don't like mushrooms. So I will remove mushrooms from the title and then remove mushrooms from the materials. This is a very, stupid and a toy exercise, just to provide an example of this. So, okay, so now we can navigate our protocol to check how this portobello breakfast was made. And just notice that there are several tabs here. So a single protocol is made of a specific description. In this case, this was the portobello mushroom and spinach. I also have the poached egg and hollandaise sauce, and I have general notes for the entire experiment. So one tab is like the general notes, one tab is the metadata, one tab allows us to add protocols, and these are the different protocols that are linked to this project. So we can, as I was doing, we can change a single tab inside the protocol, and we might even consider changing the order of the single steps inside my project. If we do that, then we should also always go back to our notes and make notes reflect, for example, the ingredients here should reflect, if I remove the mushroom, I should remove the mushrooms also from the ingredients here, obviously. Once we have made the changes, for example, I did remove the mushrooms from here. We can check the history, and again, now I have 3 versions of my file. The main file is still linked from here, but all my versions have timestamps and are somehow saved here automatically. I didn't hit any save button, right? Any change that I made is actually saved here. And I guess that's it from the exercise 3 section. Any question about this? If not, we can go to the final part of this exercise. So what if I want to share this record? I can click on the info icon on the right-hand side underneath the clock symbol, and I can export the entry. If I click that, my interface will say starting export. And at the end, I will receive an email with a zip file. I don't know how quick it will be, but I think you all will. So the zip file includes PDF versions of this protocol, and it will be shareable directly. I mean, I will be able to share the PDF version of this file. Another way to share this protocol could be to share the link of the protocol in Protocol CEO in Benchling, sorry, so people can clone their file. I will keep the breakout room open. I was yeah, whatever. Sorry. So I will be able to people will be able to clone this protocol to their own accounts. And yeah, and I guess that's it from our shared example.